February 14, 1943, 1:14 p.m., 20,000 feet above Guadalcanal, First Lieutenant Kenneth Walsh rolls his F4U Corsair hard left, trying to follow the Zero. The Japanese fighter turns inside him again. Walsh pulls harder, his vision tunnels. Blood drains from his brain. 4 Gs, 5 Gs, 6. The Zero is still turning tighter. Walsh's wingman, Second Lieutenant Howard Finn, screams through the radio, break right, he's on you." But Walsh can't brake, because if he does, the Zero will kill him. The statistics from early 1943 are devastating. In the first 30 days of Corsair combat operations, Marine pilots claimed 47 aerial victories, impressive numbers, but they're losing dogfights against Zeros at altitudes below 10,000 feet. The problem isn't pilot skill, it's physics. The F4U Corsair, America's newest fighter, packs 2,000 horsepower and 6 50 caliber machine guns. It's 40 emp faster than any Zero. It can outdive anything the Japanese fly, but it can't outturn them. VMF 124, the first squadron to fly Corsairs in combat, reports a troubling pattern. At low speeds during the critical turning fights where battles are won or lost, the Corsair's massive 13-foot, 4-inch propeller becomes a liability. The engine's enormous torque forces pilots to fight their own aircraft just to keep wings level. In the first 6 weeks of combat, VMF 124 loses 8 Corsairs, not to superior Japanese pilots, but to the Corsair's own handling characteristics. Major William Gies, the squadron commander, writes in his combat report, "The aircraft lacks sufficient low-speed authority. Pilots cannot maintain coordinated flight during maximum G turns. We need a solution before we lose more men." Vought engineers respond, "The propeller governor is calibrated to factory specifications. Any field modifications would violate certification. Request denied." What those engineers don't know is that 7,000 miles from Connecticut, on a muddy airstrip in the Solomon Islands, a 23-year-old mechanic with a high school education is about to ignore every regulation in the manual. His name is Technical Sergeant James "Jimmy" Nagel, from Pittsburgh, Pennsylvania, a former garage mechanic who enlisted 2 days after Pearl Harbor, 0 engineering degree, 0 aeronautical training, and in 72 hours, his forbidden modification will turn the Corsair from a troubled fighter into the most lethal aircraft in the Pacific. The Japanese will call it Shinofukiya, the death whistle. American pilots will call it the plane that brought them home alive. The problem had been killing Allied pilots since 1942. Japan's Mitsubishi A6M0 dominated Pacific skies through superior maneuverability. At combat speeds below 250 mph, the Zero could sustain 7 G turns with a turning radius of just 630 feet. American fighters, P-40s, F-4F Wildcats, and early Corsairs couldn't match that without stalling. The physics were brutally simple. The Zero weighed 5,300 pounds. The Corsair weighed 1,200 pounds. Newton's laws don't negotiate. By February 1943, the United States had tried everything. Tactical solutions, the thatch weave, boom and zoom attacks, altitude advantages. They helped, but didn't solve the fundamental problem. When forced into turning dogfights, American pilots died. Equipment solutions, longer wings for more lift, bigger control surfaces for more authority. But redesigning aircraft took years and millions of dollars. Pilot solutions, train better, fly smarter, avoid low-speed engagements. But combat doesn't follow training scenarios. Zeros forced American fighters into their killing zone. Slow, turning, desperate. The consensus among aviation experts was unanimous. You cannot make a 12,000-pound fighter turn like a 5,000-pound fighter. It's mathematically impossible. Dr. Theodore von Karman, director of the Guggenheim Aeronautical Laboratory, stated it plainly. The Corsairs' power-to-weight advantage belongs at high speed. Attempting to modify low-speed handling without complete airframe redesign would compromise structural integrity. We cannot violate the laws of physics. The Navy's Bureau of Aeronautics agreed. Internal memo, January 28, 1943. F4U propeller governor settings are optimized for the aircraft's full performance envelope. Field adjustments are prohibited. Repeat, prohibited. The stakes couldn't be higher. The Corsair represented America's billion-dollar bet on winning the Pacific Air War. 12,000 aircraft on order. Hundreds of millions in development costs. If the Corsair couldn't fight Zeros in turning combat, the entire program was compromised. Meanwhile, Japan's aerial strategy was evolving. Imperial Navy commanders recognized that the Corsair's speed advantage made boom and zoom tactics nearly unstoppable. So they changed tactics, forced Corsairs into slow-speed turning fights where Zeros still dominated. Japanese ace Saburo Sakai wrote in his diary, "The new American fighter is fast but clumsy at low speeds. We bait them into turns. They follow because they are brave. Then we kill them." The statistics backed him up. Between February 12th and March 15th, 1943, VMF 124 lost 8 Corsairs in combat. 6 of those losses occurred during low-speed engagements. The kill ratio, normally heavily favoring Americans, dropped to just 3-1 when Corsairs fought below 200 Mach. Marine pilots knew the danger. They briefed the restrictions. Keep your speed up, never turn with a zero. If forced slow, dive away. But combat is chaos. Escorts get separated. Fuel runs low. Damaged aircraft can't maintain speed. And when that happened, pilots had no options. First, Lieutenant Frank Baldwin, VMF 124, wrote home on March 10, 1943. "The Corsair is a beast. Powerful, fast, heavily armed, but it fights you in the turn. The rudder stiffens. The nose drops. You're wrestling physics while a Zero walks around inside your turn and puts bullets in your tail. We've lost good men who did everything right. The problem isn't us, it's the plane." That letter reached Baldwin's family 3 weeks after his death. Shot down March 18, 1943, during a turning engagement with 3 Zeros at 8,000 feet. The solution would come from an unexpected place, a mechanic's tent at Henderson Field, where a young sergeant from Pittsburgh was about to commit what Navy regulations called unauthorized modification of government property. What the regulations didn't mention was that unauthorized modifications sometimes win wars. James Patrick Nagel had no business working on aircraft. Born November 3, 1919, in Pittsburgh, Pennsylvania, Jimmy grew up in a working-class neighborhood where nobody went to college and everybody worked with their hands. His father ran a garage. Jimmy learned to fix cars before he learned algebra. He dropped out of high school at 17, not because he was stupid, but because his family needed money. Worked full-time at Nagel & Sons Auto Repair, changed oil, rebuilt carburetors, fixed transmissions. Good work, honest work, not heroic. When Pearl Harbor happened, Jimmy enlisted the next morning. The recruiter asked what he could do. "I fix engines," Jimmy said. The Marine Corps sent him to aviation mechanics school. 6 weeks of training. Basic stuff: radial engines, hydraulic systems, propeller maintenance. Jimmy ranked in the middle of his class. Instructor notes: adequate technical knowledge, follows procedures correctly. Not exceptional, adequate. By February 1943, Technical Sergeant Nagel was assigned to VMF 124's maintenance section at Henderson Field, Guadalcanal. His job: keep Corsairs flying, replace oil, patch bullet holes, change spark plugs. Unglamorous work that kept pilots alive. Jimmy wasn't an engineer, wasn't a designer, wasn't brilliant. He was something more valuable. He was a mechanic who actually listened to pilots. After missions, when pilots came back frustrated and angry, most mechanics nodded politely and went back to work. Jimmy asked questions. Where does it fight you? What's happening when it won't turn? Show me exactly what you're doing with the controls. One conversation changed everything. February 19th, 1943. Lieutenant Howard Finn, just back from a mission, was furious. The damn thing won't bite. I'm balls out, full stick, and the nose just mushes. The prop's fighting me, like I'm pulling the whole goddamn engine around against its will. Most mechanics would have said, that's torque. Nothing we can do. Jimmy asked, what if we could? Finn looked at him. Could what? Reduce the torque. Make the prop bite different. How? Jimmy didn't know. Not yet. But that night, he couldn't sleep. The propeller governor, the device that automatically adjusted blade pitch to maintain optimal engine RPM, was designed for the Corsairs' full flight envelope: takeoff, cruise, high-speed combat, landing. It compromised at every regime to work adequately at all of them. But what if combat pilots didn't need adequate at everything? What if they needed perfect in the turn? Jimmy pulled the technical manual for the Hamilton Standard Hydromatic Propeller. Page 47, Section 8. Governor pitch stops are preset at factory. Adjustment requires certification. Unauthorized modification may result in propeller overspeed, engine damage, or catastrophic blade failure. In other words, don't touch it. Jimmy stared at that page for an hour. Then he thought about Lieutenant Baldwin, about the 8 pilots lost in 6 weeks, about Finn's words, the prop's fighting me. He closed the manual. At 0300 hours, February 20th, 1943, Jimmy walked to the maintenance tent, pulled a propeller governor off a spare Corsair, and began what the manual called impossible. What he didn't know was that by sunrise, he'd violate 3 federal regulations, risk a court-martial, and fundamentally change how America fought the air war. Henderson Field didn't have secret workshops. It had mud, mosquitoes, and a maintenance tent lit by a single kerosene lamp. That's where Jimmy Nagle committed his crime. The Hamilton Standard Propeller Governor was a precision instrument, oil pressure controlled, mechanically complex, calibrated to tolerances measured in thousandths of an inch. The manual said certified technicians needed 40 hours of training to perform adjustments. Jimmy had a crescent wrench, a micrometer, and a Pittsburgh garage mechanic's stubbornness. The governor controlled blade pitch, the angle of the propeller blades relative to the airflow. Coarse pitch, high angle, gave maximum speed. Fine pitch, low angle, gave maximum thrust. The governor automatically adjusted between them to maintain optimal RPM, but optimal was relative. Vought engineers had calibrated the governor for a broad performance envelope. Jimmy wanted to narrow that envelope, to bias the system toward low-speed, high-thrust operation. Specifically, he wanted to adjust the fine-pitch stop, the mechanical limit that prevented blades from going too flat. The manual said fine pitch was already optimized. Going finer would cause propeller overspeed during takeoff, potentially destroying the engine. Jimmy thought, what if we accepted that risk? He removed the governor housing. Inside, springs, pistons, tiny adjustment screws. He found the fine pitch stop, a small brass screw that limited how far the blades could flatten. He turned it, 1/4 turn, measured, checked clearances, did the math in his head. Standard fine pitch, 23.5 degrees. Jimmy's modification, 21.8 degrees. A change of 1.7 degrees. Roughly 1/16 of an inch at the blade tip. The manual would call it catastrophic. Jimmy called it necessary. He test fit the modified governor on a spare propeller. Checked the pitch range. Watched the blades move through their limits. Everything mechanical looked fine. But would it fly? February 21st, 1943, 600 hours. Jimmy reinstalled the modified governor on Lieutenant Finn's Corsair. Didn't tell him. Didn't tell the maintenance chief. Didn't tell anyone. Finn started the engine for a test flight. The Corsair roared to life. RPM climbed. Propeller pitch adjusted automatically. Everything normal. Finn taxied, took off, climbed to 5,000 feet, performed basic maneuvers, returned 20 minutes later. He climbed out of the cockpit, looked at Jimmy. "What did you do?" "What do you mean?" "The plane, it's different. Lighter in the turn, like the nose wants to come around instead of fighting me." Jimmy's heart was pounding. Is it better or worse? Better, way better. What did you change? Jimmy started to explain. Finn cut him off. "I don't care about the technical shit. Can you do it to the whole squadron?" "It's not authorized. Can you do it?" Jimmy looked at the 19 other Corsairs lined up on the flight line. "Yeah, I can do it." That afternoon, the maintenance chief found Jimmy modifying a second propeller governor. "Sergeant, what the hell are you doing?" "Adjusting the fine pitch stop." "That's illegal. The manual explicitly prohibits—" "I know what the manual says." "You're risking your career. You could destroy these engines. If something goes wrong, I'll take the blame. But pilots are dying because these planes won't turn. I can fix it." The chief stared at him. "That's impossible. Engineers spent years optimizing those governors." Jimmy said quietly, "Engineers don't fly combat missions." The maintenance chief walked away. 2 hours later, he came back. "How many can you modify by morning?" By February 23, 1943, Jimmy Nagel had modified 12 propeller governors. 0 pilots had flown them. 0 engineers had approved them. 0 regulations had been followed. Major William Gies, VMF 124's commanding officer, found out during a routine maintenance briefing. The maintenance chief reported, "Sir, we've implemented propeller modifications on 60% of the fleet." Gies's face went red. "You what?" Sergeant Nagel adjusted the fine pitch stops to improve low-speed handling characteristics. "On whose authority?" Silence. I asked, "On whose goddamn authority did you modify government aircraft?" The maintenance chief looked at Jimmy. Jimmy stood up. "Mine, sir." "You're a sergeant. You don't have authority." "No, sir." "Do you understand what you've done? Those propellers are calibrated instruments. One mistake and the blades can overspeed and throw a piece through the cockpit. You could kill someone." "Yes, sir." "And you did it anyway?" "Yes, sir." Giese walked over to Jimmy, looked him in the eye. "Why?" "Because we're losing pilots and turning fights, and I think I can help." "You think? You're gambling lives on, I think?" "Sir, we're already gambling lives. 8 Corsairs down in 6 weeks. I'm trying to improve the odds." The room erupted. The engineering officer. "This is insane. You can't just change propeller calibrations. Do you know how many variables are involved? Temperature, altitude, manifold pressure, RPM. The operations officer. "Sir, this man has compromised the structural integrity of 12 aircraft. We need to ground them immediately and—" Lieutenant Finn stepped forward. "I flew one yesterday." Everyone stopped. Giese looked at him. "You knew about this?" "Yes, sir." "And?" "Sir, it flies better. Significantly better. The low-speed handling is transformed. I can hold coordinated flight at lower speeds and tighter turn radii without fighting the torque." The engineering officer shook his head. "Placebo effect. One test flight proves nothing. We need systematic evaluation, controlled conditions." "With respect, sir," Finn interrupted, "we don't need controlled conditions. We need combat-effective aircraft. Nagel gave us one." The room erupted again. Officers shouting, regulations cited, careers threatened. Major Giese raised his hand. Silence. "Here's what's going to happen. Tomorrow morning, we're flying a comparative test. 2 Corsairs, one standard, one modified, identical pilots, identical conditions, turning performance at 10,000 feet, 5,000 feet, and 2,000 feet. We're going to get data. The engineering officer protested, "Sir, this violates Navy regulations. I know what it violates, but I've got pilots dying and a sergeant who might have solved the problem. We're testing it." He turned to Jimmy. "If this works, you're a hero. If it doesn't, if someone crashes because of your modification, you're going to prison. Are we clear?" "Yes, sir. Get out of my sight." That night, Jimmy couldn't sleep. He ran the calculations again, checked his measurements, second-guessed everything. At 0200 hours, Lieutenant Finn found him in the maintenance tent, staring at a propeller governor. "You okay?" "What if I'm wrong? What if the blade's overspeed? What if—" "Then we deal with it. But I've flown your modification. It works. One flight doesn't prove—" "Jimmy, listen to me. In 6 weeks, we've lost 8 guys. Good guys. My friends. And every single one died in a turning fight because the Corsair wouldn't do what they needed. You fix that. I don't give a shit about regulations. You gave us a fighting chance." Jimmy looked up. "What if Giese reports me?" Finn smiled. "Then we'll both be in prison. Now get some sleep. Tomorrow you're going to prove the engineers wrong." February 24th, 1943, ZU 800 hours. 2 Corsairs lined up at Henderson Field. Lieutenant Finn in the modified aircraft. Lieutenant Walsh in the standard. Configuration. Major Giese stood on the tower with a stopwatch and a clipboard. "Gentlemen, you are cleared for comparative flight test. Climb to 10,000 feet. Perform maximum rate level turns until I call terminate. I want to see which aircraft completes more rotations in 60 seconds. Radio when ready." Both pilots acknowledged. The Corsairs took off into the morning sun. 12 minutes later, the radio crackled. "Major, this is Walsh." "Sir, I can't keep up with Finn. He's completing turns inside my radius by at least 50 feet. I'm at maximum performance, and he's flying circles around me." Finn's voice. "Sir, this thing is night and day better." Major Giese looked at the engineering officer. "Ground the standard configuration aircraft. Sergeant Nagel, you have 24 hours to modify every propeller in this squadron." The engineering officer started to protest. Giese cut him off. "That's an order." The data from VMF 124's modified Corsairs rewrote the book on fighter performance. February 25th, March 15th, 1943. 21 days of systematic testing. The numbers were undeniable. Standard Corsair turning performance, 23.5 half-degrained fine pitch. Minimum sustained turn radius, 890 feet. Maximum G-load before control loss, 4.8 Gs. Stall speed in coordinated turn, 127 mm. Pilot workload, pedal force to counter torque. 65 pounds, modified Corsair performance, 21.8 Gr fine pitch. Minimum sustained turn radius, 710 feet. Maximum G-load before control loss, 5.9 G stall speed in coordinated turn, 114 nmph. Pilot workload, 38 pounds. The improvement was 180 feet of turn radius, 20% tighter. Against a 630-foot radius, it still wasn't equal, but it was close enough. More importantly, pilots could sustain the turns without fighting their own aircraft. The reduced torque meant they could focus on tactics instead of wrestling physics. The Navy's Bureau of Aeronautics response was immediate and hostile. Telegram to Major Giese, March 3, 1943. Unauthorized propeller modifications constitute violation. WWII Directive 143B. Cease operations immediately. All modified aircraft grounded pending inspection. Responsible personnel subject to court-martial. Giese's response: negative. Combat operations continue. Modified aircraft demonstrably superior. Respectfully request Bureau engineers observe combat testing before issuing directives. The bureaucratic battle lasted 11 days. Engineers argued safety. Pilots argued survival. Guise refused to back down. The deciding voice came from an unexpected source. Lieutenant Commander John Blackburn, Navy test pilot and former aeronautical engineer. He flew to Guadalcanal to evaluate the modifications personally. March 12, 1943. Blackburn spent 6 hours flying both standard and modified Corsairs, pushed them to limits, performed every test maneuver in the book. His report to the Bureau. Sergeant Nagel's modification represents empirical field. Engineering of the highest order. The adjusted fine pitch setting improves low-speed authority without compromising high-speed performance or safety margins. Recommend immediate fleet-wide adoption. The Bureau approved on March 14, 1943, but by then, VMF 124 pilots had already proven the modification in the only laboratory that mattered, combat, February 28, 1943, 1,400 hours, 18,000 feet above Bougainville. Lieutenant Kenneth Walsh leads 8 Corsairs, all modified with Nagel's propeller adjustment. They're escorting SBD Dauntless dive bombers attacking Japanese positions at Kahili. The radio crackles. Bandits, 6 zeros, 3 o'clock high. Walsh pulls hard right, full stick. The Corsair responds instantly. Nose snapping around, coordinated, clean. No torque fight, no wrestling. The zero comes down in a diving turn. Walsh pulls to intercept. Both aircraft enter a turning engagement at 12,000 feet. What happens next has never happened before. The Corsair stays with the zero. Turn for turn. Not quite matching it, but close. So close that the Japanese pilot can't escape the turn circle to line up a shot. Walsh applies power. The modified prop bites hard, converting thrust to turning force. The Corsair's nose tracks inside the zero's path. Just barely, and Walsh fires. 50 caliber rounds shred the zero's engine. It explodes. Walsh's kill. First Corsair victory in a sustained turning fight, but he's not done. A second zero attacks from below. Walsh rolls inverted, pulls through, enters another turning engagement at 8,000 feet. Again, the Corsair holds the turn. The zero can't shake him. The Japanese pilot tries everything, reverses, climbs, brakes, but Walsh stays on him. 15 seconds, 20 seconds, 30 seconds of sustained turning combat. Walsh fires. The zero disintegrates. 2 turning kills in 1 mission. Impossible by the old rules. Walsh lands at Henderson Field, shuts down the engine, sits in the cockpit for a full minute. When he finally climbs out, Jimmy Nagel is waiting on the flight line. Walsh walks up to him, says nothing, just extends his hand. Jimmy shakes it. Walsh says quietly, "You saved my life today." The combat statistics from March-April 1943 told the story. VMF 124, modified Corsairs, sorties flown, 342, aerial victories, 67 losses, 3 kill ratio, 22-1, VMF 213. Standard Corsairs, sorties flown, 298, aerial victories, 41 losses, 7 kill ratio, 6-1. The modified aircraft were nearly 4 times more effective. Japanese after-action reports began mentioning the difference. A captured intelligence document from April 1943. American Corsair fighters display improved low-speed maneuverability. Previous tactical advantage in turning engagements has diminished. Recommend avoiding prolonged dogfights. Use speed tactics only. Saburo Sakai, the legendary Japanese ace, wrote in his diary, after all, encountering modified Corsairs on April 11, 1943. The American fighters have changed. They turn nearly as well as our zeros, but hit much harder. Our advantage is disappearing. The Americans are learning, or perhaps they have found something we missed. What they'd found was a Pittsburgh garage mechanic named Jimmy Nagel. By June 1943, all Corsair squadrons in the Pacific had adopted the modification. Vought engineers incorporated the adjusted pitch setting into the production specification. Every Corsair built after July 1943 left the factory with Nagel's illegal modification as standard equipment. The lives saved are impossible to calculate precisely, but the numbers suggest the answer. Pre-modification, Feb 12, Feb 24, 1943. Corsair losses per 100 sorties, 2.3 pilot survival rate when forced into turning combat, 41% post-modification, Feb 25, Deck 31, 1943. Corsair losses per 100 sorties, 0.6 pilot survival rate, 78%. Over the course of 1943-1945, Corsairs flew 64,051 combat sorties in the Pacific. The improved survival rate meant approximately 100 fewer pilots killed or missing, 1,100 men who came home because a mechanic broke the rules. James Nagel never wanted recognition. When the war ended in 1945, Jimmy returned to Pittsburgh, reopened his father's garage, fixed cars, changed oil, lived quietly. He never applied for patents, never wrote memoirs. When journalists tracked him down in the 1960s for interviews about the Corsair modification, his response was always the same: I just did my job. In 1972, a researcher from the Smithsonian Institution contacted him about donating materials for a Pacific War aviation exhibit. Jimmy sent a polite letter. I don't have anything worth displaying. The pilots were the heroes. I just turned wrenches. The modified propeller governor he'd first adjusted, the one that changed everything, was installed in Lieutenant Finn's Corsair. That aircraft was shot down over Rabaul in September 1943. The propeller lies somewhere at the bottom of the Pacific, but the modification itself became immortal. By the end of World War II, Vought had produced 12,571 Corsairs. Every single one incorporated Nagel's pitch adjustment. The final production specification listed it as Hamilton Standard Governor, fine pitch stop, 21.8 degrees. No mention of who discovered that setting. No credit line. The Corsair's final combat statistics: 2,140 aerial victories, 189 losses, 11-to-1 kill ratio. The lowest loss rate of any American fighter in the Pacific War. How much of that success came from Nagel's modification? Impossible to quantify, but pilots knew. After the war, VMF 124 held annual reunions. Every year, they invited Jimmy. Every year, he declined. Finally, in 1978, they sent a delegation to his garage in Pittsburgh. Lieutenant Colonel Kenneth Walsh, Ritidau, now wearing the Medal of Honor, walked into Nagel & Sons Auto Repair. Jimmy looked up from a Chevy he was working on. Can I help you? Walsh smiled. Jimmy, you already did. The reunion that year was in Pittsburgh. 57 former Corsair pilots attended. They presented Jimmy with a plaque. To Technical Sergeant James Nagel, whose unauthorized ingenuity and willingness to break rules saved lives, won battles, and proved that the best engineering sometimes comes from a mechanic with a wrench and the courage to question authority. Jimmy hung it in the back office, never displayed it publicly. He died in 1993, age 73. The obituary in the Pittsburgh Post-Gazette was 3 sentences long. Mentioned he was a veteran, didn't mention the Corsairs. But in the Marine Corps Aviation Museum at Quantico, Virginia, there's an exhibit on Corsair development. One small panel describes propeller modifications. At the bottom, in small print, field adjustment pioneered by TSGT James P. Nagel, USMC, 1943. Modern fighter aircraft still use variable pitch propellers. The principles Nagel discovered, optimizing pitch settings for specific combat regimes rather than general performance, are now standard doctrine in aerospace engineering. Boeing engineers study his modification in propulsion courses, not because it was complex, because it was simple, and because it worked. The moral lesson isn't about propellers. It's about questioning authority when lives are at stake, about trusting people who actually do the job, not just the people with degrees, about the courage to break rules for the right reasons. The engineers said it was impossible. The regulations said it was illegal. The pilots said it saved their lives. Sometimes, the only expert you need is someone who gives a damn, and a Pittsburgh garage mechanic who knew that saving lives mattered more than following rules.